Module 6, Part 2, still talking about warm cloud process. Just going over where those warm clouds occur. They occur in tropical and subtropical latitudes and have above freezing temperatures as they descend, or the area where the cloud is cold or below freezing has droplets that are so small, supercool water droplets, that they are not going to act like solids. They do not have enough mass to create a crystalline structure to be solid as they're up there. Just some other key terms. We've already gone through this. When it reaches about 5 millimeters in diameter, we can expect it to begin to fall out of the cloud or have fallen out of the cloud. Anything over 5 millimeters in diameter would take a very, very strong updraft, and that would be a major storm. So that's building something like a hailstone or incredibly heavy rainfall, and that requires some major lift, at least a cumulonimbus cloud. So we're talking about thunderstorm cloud, in that case, to exceed those sort of size and diameter and parameters to get to that size droplet. So that brings me into the factors that I can take into account to determine like how big or what type of droplet, rain droplet I'm going to be playing with. And one of them is the cloud liquid water content. So how wet is the cloud? We're talking about some form of cumulus cloud. So we've gone through the different cloud types. I'm not talking about a cirrus cloud. I'm talking about at least a cumulus cloud. And it has to be in the lower altitudes or incredibly vertical. So a cumulonimbus cloud being vertical, a cumulus cloud being something that is in my lowest layer, my strata clouds, right? And so I can see a stratocumulus cloud raining on me. And I can sometimes get the middle clouds, so the alto clouds. So an altocumulus cloud could conceivably rain on me. But anything way, way up in the cirrus, so my high altitude clouds, I would never get rain. And so that goes into the liquid, the amount of liquid present and the altitude that the cloud is occurring at, or the lifting condensation level, the base of the cloud is occurring at. The range of droplet size will determine what's going to happen with my cloud. Cloud thickness and vertical reach, it's just going through that. The amount of updraft, so how much updraft is holding these cloud droplets buoyant up there so that they can gain size or gain mass. And then the final one is the electrical charge of water droplets, the positive and negative ionic activity that is allowing them to coalesce together, right? So that this is taking place. All right, so that brings us to cold cloud process. Cold cloud process, also known as the Bergeron's process, takes place with ice crystals. So I am actually making little ice crystals within my cloud. Now, little word of warning here, I can have ice crystal process all year round. And one of the key things to keep in mind is that within my cloud itself, I can have ice crystals and I can have rain droplets. And I can even see those ice crystals come out of the cloud, but they actually melt on the way down. So by the time they get to the ground, it is raining. And that's actually pretty common. So where we live up near Valhalla, it's pretty much snowing all year round if I can get to the lifting condensation level of that cloud that is dropping that material and actually see what's coming out of it. I would find that they are ice crystals, but when they're leaving the cloud, they're reaching temperatures that are above freezing and they are melting, so that they're melting before they ever reach the ground. So they end up being rain by the time they hit the surface of the earth, but it's snowing up there in that cloud. So ice crystal process will take place on an ice crystal nuclei, and an ice crystal nuclei can be made up of any material that allows the solid structure of water to stick to it. And this tends to be certain types of clay minerals that are in the atmosphere. So it's an aerosol particle. Bacteria would be considered an aerosol particle, specifically a certain type of bacteria that comes about or clings off of leaf litter material. And then ice itself, ice crystals themselves, One of the big mysteries of the Bergeron's process is the how we get from only a small number of ice crystal nuclei found within the cloud to the sheer magnitude of ice crystal nuclei. And it was discovered or confirmed what many scientists believed fairly recently, that the way that we increase the number of ice crystal nuclei within the cloud is the actual shattering or breaking of ice crystals within the cloud itself, allowing it to go from just a small number, and it would be, let's say 2%. If that 2% all cracks and breaks, and I even just double it, I get 4, and then that 4% cracks and breaks, and I end up with my 8%, and I just keep going. And so they keep shattering till they get to such a magnitude and such mass that gravity pulls them back down to Earth, right? And that's how it's occurring. So we mentioned saturation vapor pressure in the previous modules, and I even showed you how to do some stuff with the terminologies and saturation vapor pressure and maximum amounts of water, of saturation water amounts based on the saturation curves, right? And one of the key things to keep in mind is that the ice crystal itself would have greater saturation vapor pressure, meaning that this would be the low pressure region, and this would be the high pressure region, which means that water droplets near ice crystal nuclei will actually move as singular water molecules to the ice crystal nuclei. And this will happen in all directions. So while the artist picture here is just showing the one water droplet moving molecule by molecule over here, it's actually coming in from every direction around this ice crystal from all of the supercool water droplets surrounding it. So all of the supercool water droplets are losing mass to the ice crystal nuclei, becoming a solid ice crystal and gaining mass itself. As this occurs, the water droplets that stick to the ice crystal nuclei will do a process called accretion, because they cannot coalesce. So they cannot be taken into it. All they can do is freeze along the exterior. And so when I'm freezing along the exterior, this process is called accretion. So once my ice crystal accretes enough material to gain enough mass, it will begin to get pulled down through the atmospheric layers. Once this process begins, I can also start to collide with supercool water droplets as well as other ice crystal. And if I happen to collide, as my little snowflake self, with an ice crystal, or I hit a supercool water droplet at specific angles, I can shatter. And when I shatter or splinter into smaller ice droplets, I can then see all of the little particles that shattered off begin to go through their own saturation vapor pressure accretion process, gaining their own mass. And then once again, when those get large enough, they will begin to get pulled down by gravity through the cloud layer, right? So I'm going down through the cloud itself to reach the ground. Now, this little graphic on the side, I want to just point out to you because it does a nice job at showing you temperature within the cloud itself and then falling through the air regime. So you have to imagine the top of the graphic is the lifting condensation level. So that's the base of the cloud. And then everything from here down where it says deep cold layer here in the blue is the cloud material falling. And I can see that the atmospheric temperature does not ever exceed, as I'm falling down, does not ever increase or exceed or go over the 32 degrees Fahrenheit, which would be my melting temperature, right, in Fahrenheit. And so I can expect snowflakes in this case. And snowflakes are literally ice crystals that have come from the cloud all the way to the ground and have maintained their shape and structure as they were forming, right, as they were forming their crystalline structure. Another one that we can see down here has to do with how I get a kind of sleet material where I start out as clouds, as snowflakes, sorry, and then as I reach down, I get warmer then, and I melt to become liquid, and then it gets colder again as I'm getting pulled down through the atmosphere, so I refreeze, and I fall as sort of a sleety, freezing material. And this is freezing rain down here, this one down below, where I'm coming out of my lifting condensation level of the cloud as snowflakes, but I'm pretty much melting instantaneously. and I'm warmer, 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 but then when I hit the ground, everything on the surface is below freezing, and so I'll freeze on contact as a water droplet. So on this note,